going to see the properties of the wave. We will see the frequency, the velocity or speed, the wavelength, and the intensity. So here we have could be the graph of the wavelength, but don't always the graph is the same as the real form of the wave. So here we have, let's say, this shape. First we have the amplitude. The amplitude is from the equilibrium, that is this line, to the maximum point or to the minimum point. In this case, this should be the same point, something like this. So this is the amplitude, or this is the amplitude. So from these are called the crests, and this is the throat. So from one crest to a throat in the vertical direction, it would be twice the amplitude. And so the height of one crest or the depth of one throat is the amplitude. Now the wavelength is the length between 2 points in which they are repeating. So it could be between this point and this point, or this point and this point. So from one crest to another, from one throat to another, or could be from this point to this point, this point to this point, wherever repeating points are. So this distance would be the wavelength from all these. All these would be the wavelength, and this is expressed as lambda. Then we have the frequency. We can have another wave that behaves like this. So here the frequency is very high, and the wavelength, that is the distance from this point to this point, this wavelength is very short, but the frequency is high, so the pattern is repeating many times. So if the wavelength is high, then the frequency is less, like in this example. Or if the frequency is high, as in this example, then the wavelength would be decreasing. So the units of wavelength are in meters, or feet, or centimeters, or whatever. The units of frequency are how many times are these occurring. So the frequency is in seconds, like how many cycles per second. Cycles per second. So cycles is not a unit, so here we're just talking about the seconds to the -1. And so the velocity of the wave, the velocity is wavelength times the frequency, because here we have meters and here we have frequency. Units are 1 per second, so here we have meters per second. So the velocity of the wavelength is lambda times the frequency. All the wave has the same velocity. All the waves of the same kind, for example, this sound has the same speed always, that is 1,100 feet per second, or like 333.3 meters per second. But we have different sound waves, but all compared to the same velocity. So because the velocity is the same, then we can only modify the length and the frequency. So if we have a wave that has greater wavelength than other wave, so the frequency will be decreased, but the velocity is always the same. For the sounds that we can hear, the wavelength that we can hear goes from 0.16 meters to 16 meters. So from 16 centimeters to from 0.016 meters, 0.016 meters. So this is like 1.6 centimeters to 16 meters. These are the range of wavelengths that of the waves of the sound that we hear. A wavelength that has frequency above 120 per second, or hertz. Hertz is the same as 1 per second. It can damage the ear. So whatever be higher than this will damage the ear. Alright. Now let's see the period. The period, represented as T, is 1 over frequency. That is, in frequency we're saying how many cycles per second. In the period we are saying how much it takes to complete one cycle. So here we have let's say that the frequency are 15 cycles per second. Then we want to know how much does it take to complete one cycle. Then it will be divided by 15, so it will be 1 over 15 seconds is what it takes to complete one cycle. So the period, the units are in seconds, and it's just 1 over the frequency. Also we have the omega. Omega is the angular frequency. So this is 2 pi times the frequency. So it's just the same as the frequency, but in radian units. Well, radians per second instead of just 1 per second. So this is because one cycle, one round is the same as 2 pi. So here, instead of saying 15 cycles per second, we could say 30 pi rads per second is the angular frequency. And the intensity is power per area. So here we have watts per square meter. So the intensity is directly dependent of the amplitude. If we have more amplitude, we have more intensity. Now the intensity usually we measure it in decibels. So here we have decibels. Decibels like 0, 10, 20, 30. Here we have the intensity, and here we have the in units of power of watt per square meter. So 0 corresponds to 10 of intensity. 10 decibels are 100. 20 is 1. Sorry, here was 1, 10, 100, 1000. So it's just the intensity is 10 elevated to the power of the decibel numbers, and now in watts per square meter, this is 10 to the minus 12. So watts per square meter, so this will be 10 times more, so it will be 10 to the minus 11, 10 to the minus 10, 10 to the minus 9, etc. So these are the measures of intensity. And just for energy, the energy is depending on the frequency, and also you can see it as on the wave, because frequency and wavelength are related, whatever, and also the Planck constant. Well, but here the point of the energy is that the energy of the wave, for example, this wave, is constant. That is when the wave is propagating, has the same energy as this wave, that is the, let's say, the wave that already has propagated, if we discharge the energy that has been lost on the heat. So because this wave has the same energy as this wave, if we take a piece of the wave, for example this piece has less energy than, for example, this piece, because in this wave the energy is divided on this cycle, and here the same amount of energy is divided on this bigger cycle. So the energy, if we discharge the heat, the energy remains constant. But because the heat or friction is occurring in the real life, the energy, and remember that what travels along the wave is energy, not mass. So the energy actually is decaying with the square of the distance. So linearly with the area. So here the energy will be, energy is inversely proportional to the square power of the radius. And here we're talking about, for example, when we drop some object on the water. But if we do, for example, in the sound, that the sound is a spherical wave because it's on 3D, then we are talking about a sphere and not a cycle. So the area of the sphere is the derivative of the volume. The volume is 4/3 by r to the cube. Then the area will be 4 by r squared. And because the energy is decaying with the here with the square, so with the area, then and here we have area is equal to 4 pi to the r square. We have that energy is inversely proportional to the square of the radius. So we already saw the amplitude, wavelength, frequency, period, and the energy.